Yes, okay, okay, recording. Yeah.
Okay. All right. So today we are doing applications of nonlinear functions. Okay, the learning objectives for this chapter, set up quadratic revenue, cost, and profit function, and then optimize quadratic revenue, cost, and profit function, determine market equilibrium for quadratic demand and supply function, um, determine break-even points, quadratic total revenue, total cost, and profit functions. So before we can start applying the nonlinear functions, we need to know the properties of a quadratic function. So when you talk about the nonlinear, it means that now we're talking about the functions that are not a straight line. When you put them on your Cartesian plane, or when you draw the graph in this chapter won't be a straight line. That's why we are saying it's a nonlinear function. So we are going to focus on the properties of a quadratic function. So in this chapter, we'll be focusing on quadratic functions. I'm aware that we have exponential, hyperbolic, but then we are only going to focus on quadratic function. And in the general form for a quadratic function is ax squared plus bx plus c. A, B, C, they are your constants. And then the quadratic formula, we have a quadratic formula. Sometimes they call it a B minus formula. This is the one, it's x is equals to negative b plus or minus the square root of b squared minus 4ac over 2a. And then it says here that it is used to find the roots. So when you're talking about the roots, we're talking about your x in this case of a quadratic function. And then when we have a plus or a minus, it means that we are going to have two answers when we are using this formula. And then we have another property. We have a turning point. And then when we want to find the turning point of this function, we're going to look for the x value. It's going to be x is equals to negative b over 2a. And then after that, you use the x to find the y value. So for an example, let me start with this formula first. So with the formula, this is what tells us that the function is a quadratic. So the square there, it means that your function is a quadratic. So every time you have a formula or you have an equation, yes.
It's here. On my side, I cannot see your screen. Not sure
Yeah,
if there's something wrong on my side.
Yeah, can you, how can I say it? Can anyone see my screen besides Teboho?
Yes.
Yes, so Teboho, you can.
Yes, I can.
Yes, just give it a chance, or maybe.
I can see the screen, yes. Oh, God.
Okay.
Yes.
Yeah, try to, I don't know, exit and enter, or yeah.
Yeah, let me exit and rejoin.
Yes, yes.
Okay.
Okay. Okay, please mute your mic. Thank you. All right, so as I was saying, for us to know that a equation or a formula or a function is a quadratic function, you are going to see it with the square there. And then we say that A, B, C are your constants. So these are the constants, your A, your B, and then your C. They are your constants. Can be any value. And then now when coming to the quadratic formula, I said that with this one, you're going to have two roots, or you're going to have two answers for x. So, and then now I was talking about the turning point. So when you're talking about the quadratic function, your graph looks something like this. Your graph is going to look like this. For an example, it's just an example. Let's say our variables, it's X and Y. So if this is your graph, your Cartesian plane or a plane, and this is X and this is Y. The quadratic function, it looks like this. Sometimes it's facing up, sometimes it's facing down. So it's going to look something like this. And then with the quadratic function, this point, we call it a turning point. This is where our graph is turning. So that's our turning point. So with the turning points, you have 2 points. Obviously, you have two coordinates, one coordinate with X and Y, I mean. So you're going to have something like this. So if you can check this graph, you'll notice that this is the highest point of our graph. So we call it the maximum point. So this is the maximum point, the highest point of this graph. And then this is where our graph is turning. So this is what we call the turning point. Turning point, and it's also a maximum point. So if I want to look for the X value here, I'm going to use this formula where it says negative B over 2A. So obviously before I draw the graph, I am going to use this function, AX squared plus BX plus C. So I must be given this for me to draw this graph. And then now we move on to okay, here it says that a quadratic function has a minimum where your A is less than 0 or a maximum where your A, okay, here I made a mistake. So when your A is less than, we get, when your A is greater than, not less than, sorry, let me correct myself here. So here we get a minimum when your A is greater than 0. Because it will be facing up. Oh, sorry. So we get the, okay. All right. So when your A is greater than 0, so meaning that if the sign of your A is negative, remember A is your constant. So this, it means that if A is negative, if A is negative, that's when I will have a minimum turning point. But then if my A is less than, this is positive, sorry. If my A is less than, it means that if the A here on my function is a negative number, I'm going to have a maximum. So this means that if my A is negative, yes, it's a minimum if A is positive, and then it's a maximum if your A is negative. And then we have what we call a discriminant. So the discriminant is an expression that is under the square root, yes?
Can you please just repeat the turning point part? When it's,
okay.
Sorry.
When A here on your expression or maybe on your function, if this number A is positive, your graph is going to have a minimum. So it means that your graph is going to face down. It's going to face up. So let's say it's going to look something like this. Then this will be your minimum point. And then if my A is a negative number, my graph is going to look like this. It's going to look like this one. It's going to
Okay, I
face
get
down.
you. Thank you. Thank you.
Yes. Okay. All right. And then we have what we call a discriminant. A discriminant is an expression that is under the square root here on your quadratic formula. This part of the formula, we call it a discriminant. And then it says here that the discriminant is used in economics when solving quadratic equations that arise in revenue, cost, profit, or demand functions. It helps determine how many solutions, in brackets, break-even points or equilibrium points, a quadratic equation has. You will see when I do an example of break-even points that you can have two points. And then it says here that A, if your discriminant is greater than 0. So meaning that if I substitute my A, B, and C, and then I get a positive answer, the graph has two different real roots. So it means that when you're talking about the roots, we're talking about this X. Again, it will make sense when we do an example here. And then it says that if b squared minus 4ac is equals to 0, when you substitute the constants and you get the answer that is 0, then the graph touches the x-axis at a single point. So it means that now at a single point, if this is my graph, let's say it's facing up, my graph is only going to touch this at one point, this part of the graph. This is x, this is y. It's only going to touch it at one point. If you can check here, my graph is touching x at 2 points, 1, 2. So that's what we mean. But again, I'm just giving you the background. You're really not going to use, you're not going to use this, but let me just teach it. So if b squared minus 4ac is less than 0, when we say less than 0, we mean that when you substitute the values here and you get a negative answer, then it means that the graph does not touch the x-axis. So what do we mean? We mean that if this is your graph is not going to touch. So your graph will just be here, facing up or facing down. It's not going to touch this line of x. That's what we mean. So now let's look at our application of nonlinear functions now in economics. So here I was just giving you the background of maths. And now I'm going to teach you this now in economics. It's going to make sense here now. So now we're going to optimize quadratic revenue, profit, and cost function. So the revenue function is, we know it as TR is equals to P times Q. And then now when we are doing it in the nonlinear function as a quadratic, it's AX squared plus BQ plus C. So this is the function with respect to Q. So now in this case, Q is our X. In this case, Q is our X. All the formulas that I taught you, they apply. So it means that my turning point here, my turning point here is going to be Q. Instead of X, I'm going to have Q. So I will have Q is equals to, instead of X, I have Q. So this will be Q is equals to negative B over 2A. So in this, we also have a quadratic function. Why? Because of this 2. If you have a power of 2 in your function, it means that the function is a quadratic. There's a curve. It's not a straight line, it's a quadratic, so it's going to be a curve. And then also same applies with your profit function and also with your cost function. They're all going to use this. If you want the turning point of these 3, the formula is Q is equals to negative B over 2A. And then if I want the roots, these roots that I was talking about, this one, if I want to use the quadratic formula, the formula in economics, it's going to be Q. Our formula is going to be Q is equals to negative B plus or minus. The plus or minus, it means that we're going to have 2 answers of Q. This is B squared minus 4AC and then over 2A. As I said, this is a function of Q. So the difference between what I was doing and this one is that it's only Q. That's the difference. So if I was to draw the function, let's say for your total revenue, my graph is going to look like this. It's still the same thing as the one that I was drawing before. So I'm going to have a graph looking like this. So because of this is total revenue is going to be TR. So this is TR. That's my dependent. And then my independent is Q. We drew the graph of total revenue as a linear before. So now we are drawing it as a quadratic. So our graph is going to look something like this. And this will be a parabola. quadratic, it's gonna look something like this. Just an example. And then if it looks like this, and then this is my turning point. So as I said, my turning point is my maximum. This is the maximum point. The maximum. So this is my turning point. So the turning point in here, sorry, the turning point here is my maximum. So this is what you call the turning point. So it means that at this point, my total revenue. So at the turning point, my total revenue is at its maximum. When my graph looks like this, the turning point, the total revenue is at its maximum here. So if I ask you to maximize, it means that I need to, if I say what is the maximum, it means you have to find this point here for me. But then you'll see it as when I do an example. And then profit function, you know that profit is equals to total revenue minus total cost. We also know the total cost is equals to the fixed cost plus your variable cost. We all know that, the total cost formula. So now let's look at the example so that everything can make sense. Here they're saying consider the demand function for a monopolist given by function P is equals to 100 minus 2Q. This function is in terms of Q, this function, your demand function. So they're saying where P is the price per unit of a good and Q is the quantity produced and sold. Number A, it says write down the equation for total revenue function. So we all know that the total revenue function, the formula for total revenue function is it's TR is equals to P times Q. And then if you can see here, we are given the price. P is equals to 100 minus 2Q. So I am going to substitute, I'm going to replace. So this will be my TR is going to be equals to my P. I'm going to put it inside the bracket. It's 100 minus 2Q and then times this Q. So times this Q. And then now I'm multiplying, I'm going to distribute. So when you have a bracket and a number outside, we distribute. So it means you must multiply everything inside the bracket with the Q. So this will be 100 times Q. And then I am going to get 100Q. And then I'm going to say negative 2Q times Q. When you multiply a Q with a Q, you get a Q squared. So this is going to be 100Q. And then when you multiply a Q with a Q is a Q squared. Those who know, they know that X times X is X squared. It's the two of them. So when you multiply letters, you square them.
You forgot to put 100Q.
100Q, so thank you. 100Q. Yes, 100Q, thank you. 100Q. So this is my total revenue. So you will notice that the function of total revenue is a quadratic. Why? Because there's a square there. Every time there's a square, it's a quadratic. So if I was to draw the graph, my graph will either look something like this or it's gonna face up. And that only depends on the value of A. So don't forget that we said that the standard form for a total revenue, it's TR, okay, is equals to AQ squared plus BQ plus C. Okay, so let's go to the next question. I think that will explain it better. The second question, it says, determine the number of units that needs to be sold to maximize total revenue and calculate the maximum total revenue. So now we need to calculate Q. All right. And then if you can remember, we said that TR, I said that TR is a maximum at its turning point. That's where the total revenue is at its maximum. And then I need to calculate the units at its maximum. And then we have the formula. All right. So the equation that we have, and let me write this so that we don't forget. I said that the total revenue as a quadratic is going to be A Q squared plus BQ and then plus C. This is the standard form of a total revenue quadratic function. And then we have from our A, we have a total revenue function, which is TR is equals to 100Q minus 2Q squared. So we are going to compare these two functions. So this is a standard one. A total revenue function is supposed to look like this. AQ squared. So it means that a number that is next to Q squared is A. A number that is next to Q is B. And then a C is alone. It doesn't have a Q. So this means that when I write this down, I have to write my A, B, C. So A, Tobani, your hand is up.
Yes, ma'am. Can we sort this equation of TR starting with -2Q squared plus 100Q?
Or you want me to rewrite it? Okay.
Yeah,
I can do that. Yes, I can do that.
With the -2Q, like
Yes, I
negative
can do that.
plus 100Q. Thank you.
Thank you, Tobani. So it's gonna be -2Q squared, then plus 100Q. I can do that also. Thank you. Yes. So now we can write our A, B, and C. So what is our A? When you look at this, you can compare these two. Compare this one with this one. What is next to Q squared? Whatever is next to Q squared is our A.
Negative
So what is next to
two.
Q squared?
-2.
So it's
Negative.
-2. And then what is next to B?
100.
100. And then do we have C?
No.
No.
So we put 0. Thank you. So we're gonna put 0. All right.
Yes, maybe
Then
zero.
now, yes, and then now we can calculate, because we have to look for the Q at its maximum. So we have to use that formula that I showed you, this one. This is where you find the Q at its maximum. So we are going to use that formula. So this will be Q at its maximum is equals to -B over 2A. And then we replace now. So we're gonna replace with our B. So this will be negative. And then our B, we'll put brackets, is 100. And then this is over. And then I put 2. And then I'm going to replace A. My A is -2. And then you use your calculator. What is the answer?
25.
25. So it means that this will be 25 units. This is 25 units at its maximum. So we answered the first part. So this 25 units at its maximum. And then now we have to calculate a maximum total revenue. So if you can remember, our function looks like this. Let me just draw it here again. Our function looks like this. And I said to you that if our A is negative, so our function is going to look something like this. I'm not going to draw the whole thing. This is TR, and then this is Q. So because A is negative, then it means that it has its maximum. So it means it must face like this. So my graph is going to look something like this. So it means that here I have 25 units. Now, if I say, calculate the maximum total revenue, it means that I'm looking for this one. This is the maximum value of total revenue. So when you look for the maximum value of the total revenue, you just go into substitute your units, your Q. So remember the formula, our formula is TR is equals to 100Q, or maybe negative, it's up to you, choose which one you want to use, minus 2Q squared. And then now we are going to replace or substitute. So this will be 100. We said our Q is 25, so we're going to use 25. So it's going to be times 25, and then minus, and then this is 2. Then we replace the Q again with 25. Don't forget the square. This is 25 all squared. And then now we get the answer. What is our answer?
1,250.
1,250. 1,250. So this means that when 25 units are produced and sold, a maximum total revenue of 1,250 is made. So it means that this is our maximum total revenue, 1,250. I saw there was a hand up. I don't know if I answered your question. This is the first thing that we do, and then this is the second thing that we do. Yes, Angezila. Okay, Angel, I don't know. Yes, sorry if I pronounced your name wrong. Yes. Yes.
It's fine. Masik, I'm so sorry, but I don't understand the first step. The second step I do, but I don't understand. I don't know how you got to the A and the You lost me there. I'm so sorry.
Okay, wait. Where are we now?
Where you are basically placing, you're saying A is equal to -2 and then B and then C. I'm not understanding that part.
Okay.
And the
All
first
right.
step after that. Only that part, please. Sorry.
Oh, okay. It's okay. So when I started, I said we have what you call a standard form, ne? A standard form is where a formula is supposed to be. This is how it looks like. Should you have a formula? So the
Okay.
total revenue formula looks like this. Let me just write TR here so that it makes sense. So the total revenue, it's supposed to look like this because it's a quadratic, so it has a square. So
Okay.
it's TR is equals to AQ squared plus AQ squared plus BQ plus C. This is how it's supposed to look like, ne? And
Okay.
then the profit function, it's supposed to look like this. Then A, B, C are your numbers, can be any number, but the Q squared must be there and also Q must be there. The others are just numbers. A, B, C can be any number. So if C is not there, it's a 0. If you have A and B, they're just going to be a number. And then the profit function also looks like this. It must also look like this. Oh, this one is just P is equals to. And then same applies with the total cost. The total cost function in this chapter, they're supposed to look like this. Every time they say quadratic, they're supposed to look like this. The 2 makes it a quadratic. Yes.
Okay.
So the first question, we're looking for the total revenue function, right? We got
Okay, now I
T-
got that part. I understood that part. It's
yes.
just, yeah,
Okay.
so it's just
Yes.
where you
Yes, I'm
started to
moving.
place A is, okay, no, go ahead. Sorry,
Yes,
I'm
I'm
sorry.
moving. Yes, let me explain. Yes. And then now B, we're supposed to calculate the maximum total revenue. The Q, they wanted the Q at the maximum total revenue. So I said to you, we have a formula to calculate the Q. But then you cannot calculate the Q if you don't have the total revenue formula in a standard form. So the standard form, it's supposed to have AQ squared, right? Then plus BQ plus C. So when you look at this one, you will see that we have 100Q minus 2Q squared. And then a gentleman said we should write it in this way. He wanted us to write it in this format. That's what he wanted, right? And then when you look at this, if you compare these two formulas, if you compare TR is equals to AQ squared plus BQ plus C, I said to you, whatever is next to Q is your A. This is your A. Whatever is next to Q is your B.
Next to Q squared.
Yes, next to Q squared is your A, next to Q is your B. And then our total revenue function, we don't have a C. There's no plus anything. So every time you see a total revenue under this topic of non-linear, whatever is next to Q squared, whether it's here, whether it's there, it doesn't matter. That's your A. Whatever is next to Q, that's your B. So then I wrote them here. I said my A is -2 because the number that is next to Q squared is -2. And then the number that is next to Q is 100. And we said that whatever is next to Q is your 100, is your B, sorry. So this is A, this is B, and then that's C. And then this is my A, this is my B, this is my C. Where? In this, the one that I have. This is just the formula. It's just the standard it's just the formula. We are saying that it should look something like this every time you look at the total revenue of nonlinear under quadratic. And then I said that this is the formula to look for your units at its maximum. It's Q is equals to -B over 2A. What is my B? My B is 100. Remember, we are calculating based on this function that we calculated. My B is 100, and then 2, then my A is what? -2. There it is. And then I just used my calculator here. Then I got 25 units.
I got you. Thank you so much. You were star. Makes it.
Okay.
Sorry.
It's
Thank you.
okay. Yes, I see 3 hands up. Tebogo? Tebogo.
I have a question. Yeah, my question
Yes.
is, let's say during the exams, right? Are we gonna be provided with the formula sheets, or we need to memorize all these formulas?
Remember we said that our assessment is always open book.
Okay.
Yes, it's open book. So meaning that before you write your exam, you must make sure that all your notes are in front of you and they're in order.
All right. Thank you.
Yes, pleasure. Next, I saw a hand up. Now I can see. Okay. All right, no one is saying it. Okay, let's mute your mic. Mute your mic if you're not asking a question. Mute your mic.
Masako, just to ask, when you say open book, right, and we can have our notes with us, is this inclusive of the study guide? Can I open my study guide as well?
Yes.
Like the whole entire study guide?
Yes.
Oh, okay.
Yes.
Excuse
Yes.
me, teacher. Excuse me, lecturer. I'm so sorry to interrupt you. So you said
Okay.
assessment one is all in like the open book, and so can I just so I doing the test quiz, and then can I see the notes? Some notes like the can I see the notes, because I think it's the open book, right? So can I see the
Yes,
notes?
you can. Yes, you can use your notes. Are you asking if you can use your notes?
Yes.
Yes, you can use your
Okay.
notes.
Okay, thank you. Yes, thank you.
Yes,
Thank you so
pleasure.
much.
Yes. TD, your hand is up.
Sorry.
Okay,
Bye.
as Buthelezi. Oh, Yonela. Okay, yes.
Hello, can you hear me?
Yes, I can hear you. Can continue.
Yes, my question is for Q. In what instance do we use the square root function, and in what instance do we use the one without the square root?
Okay. So with this one, I said with this one, you're going to see when I use it at the break-even point. This one. We are going to use it at the break-even point. You will see. So you use the Q, ne? You use the Q if you have to solve for Q and you have a Q squared. You'll see it when we do equilibrium. That's when you're going to see that we have not equilibrium, break-even point. That's where our function is going to have Q squared. When you have a Q squared, and then, yes, when you have a Q squared, you also solve for Q, you're going to use this one. You're going to see that break-even point. At break-even point, that's where we're going to use this one, where we're going to have two values of Q. At this one, they just wanted the number of units that needs to be sold at the maximum total revenue. So at this point, but then you'll see when coming to break-even point, you're not going to have a choice of using this one, but this one. You'll see it when we do it. I think it will make sense when I do conversation. When I explain it, it's not making sense. But let me go through with the examples, then you'll see it's going to make sense. Break-even point, that's when we use this one. Total revenue, total costs, we use this one. The turning point. If they say TR at its maximum, this is what you use. And then with total revenue, not total revenue, break-even point, you'll see it when I do it. Yes, next. I'll answer your question when I do the example. You'll see. Dineo. Yes, Dineo.
Oh,
Is it based on this? Can we please ask a question based on B?
okay. Just a
Because I'm
quick
not
one on
done.
that.
Yes.
Sorry. Hi. I see that we are calculating the maximum total revenue. Will we ever be asked to calculate the minimum now to make the turning point, what you call upside down?
Yes, you
And
will
are we
see it.
using the same formula?
Same
Or
formula. Remember,
we-
yes, same formula. Remember the notes here. If you can remember, I said that here. Here. Ne? I said that a quadratic function has a minimum if a is greater than 0, and then has a maximum if a is less than 0. So, and I said that a greater than 0, it means that the value of a is positive, and then a less than 0, it means the value of a is negative. So if you can look at our function, total revenue function here, our a is what? It's negative. That's why we had to calculate the maximum. Yes. So it means that if it was positive, then it would be a minimum.
Okay. No, thank you. I
Yes.
hear that now.
Okay. Next, only B. Now we are asking questions based on B only because I have to continue with the examples. Yes. Sorry. Yes, you can ask.
Sorry, ma'am. Evening. I just wanted to ask, please kindly repeat that, ma'am. You said we use a revenue function to calculate TR, right?
TR is total revenue, yes. I said that to calculate the maximum of total revenue, we always have to start by looking for Q. These are the steps. First thing, you look for Q, and then after you find the Q, using the turning point, because this is the maximum of the graph. This is the maximum.
Yes, ma'am.
So we use this formula to find the Q. Then after you find the Q, the second step, you substitute your Q into the formula that you got, the TR formula, total revenue. That's how you find this. Yes.
Which one do we use for break even?
Break even is this one. You will see it. I think it's better if we wait for the example. I think it's going to make sense when I do the example. Yes, it's the last example. Yes.
Oh, thank you so much, ma'am.
Pleasure. Was there anyone with a question? Last person, please. A B, only B. Then the others I'll entertain when I'm there. You'll see it. Anyone? No one? Okay, let me move to the second example. I think it's going to make sense. Let me move to the second example. Okay. They're saying that a firm's total cost function and demand function are given by TC is equal to 200 plus 3Q, and then PD is 102 minus 2. So this is the demand function, and this is the total cost function. So where Q is the number of units of a product produced and sold. A says, write down the total revenue function. So we know that the total revenue function is TR. Sorry. It's TR. TR is equals to
PQ.
PQ. Thank you. P times Q. So it's PQ. All right. And then we see that our P is given there. It's a demand function. Our P is 10, so I'm going to use a bracket, 107 minus 2Q, and then times this Q. So we just substitute, and then now we are going to distribute, meaning we multiply everything with Q. So we are going to say Q times 107, it's going to be 107Q, and then negative 2Q times this, it's going to be a negative 2Q squared. Again, because of it has a square, it means that this is a quadratic function. And then now we move on to number B. Number B says determine the profit function for the firm. If you can remember, profit is equals to total revenue minus profit is equals to TR minus total cost.
Total cost, yeah.
And yes, and then we have our total cost. We also have our total revenue. So we are going to minus the two. So because they are functions, I'm going to use brackets for TR. I'm just going to separate these. Q minus 2Q squared. And then I say negative, this negative that is between. And then TC, total cost, is 200 plus 3Q. And then now I am going to minus. So I cannot minus with the brackets. I must remove the brackets first. BODMAS, brackets first. So we are going to distribute this negative. So I'm going to distribute this. This one, there's no sign here, so it's going to remain the same. So this bracket, I'm just going to remove it because there's no sign in front of a bracket. If there's a sign in front of a bracket, it changes every sign inside the bracket. So this negative is going to change this. It's going to be a negative because it was a positive 200 was positive. So now it's going to be a negative 200. And then the 3Q also is going to be affected. It's going to be a negative. If it's a positive, it's a negative. If it was a negative, it was going to be a positive. So this will be a negative. This negative changes all the sign. So this will be negative 3Q. And then now we are going to do apples and bananas. Collect like terms, yes. So this is equals to, you will notice that 107Q is the same as 3Q. They both have Qs, they're both bananas. So I'm just gonna write this like negative 2, yes, like terms. So I'm gonna write this negative 2Q first because it doesn't have a friend. And then I'm going to say 107Q minus 3Q. It's going to give me a positive. You can use a calculator.
104.
It's going to give us 104. Yes, a positive 104. Then this is just a negative 200. Someone will ask, why am I writing it this way? Remember, I said that the standard form for a profit function in quadratic, it's P is equals to AQ squared plus BQ and then plus C. Lucille, do you see it now? Lucille. Okay.
Oh, me. Sorry.
Oh.
Yes, I do. I didn't
Yes.
answer that question. That wasn't me.
No. I mean, do you see the standard that I was talking about? The for profit,
yes, I do. Thank you. Sorry. Thank you. I do. Thank you.
Yes. So now you can see this is the same as this. Our A is negative 2. Our B is positive 104. Our C is negative 200. Okay.
Thank you.
All right. And then now we go to C. So C says determine the maximum profit. I said to you, when you determine the maximum profit, step number 1, or maximum anything, you first look for Q. When you are maximizing, 1, you look for Q. 2, you look for whatever. Here we're going to look for profit. So now we know that our profit formula, the function that we obtained in the previous question, is P is equals to negative 2Q squared plus 104Q and then minus 200. That's our profit function that we obtained before. Mpondo, I see your hand is up. Can I finish and then I'll attend to your question, please? Let me finish first. I'll attend to your question. So this is our standard profit function. This is our profit function, sorry. Now we're going to look for A, B, and C. So our A is negative 2. Our B is 104. And then our C is negative 200. And then now, we look, step number 1, I said we look for Q. We know that Q is equals to negative B over 2 times A. And then we replace our B. So this will be negative. Our B is 104. So I'm going to do this again. So 104 and then over 2. And then our A is negative 2. Then negative 2. And then we use our calculator. What is the answer?
26.
26. So now we found our Q. Every time they say maximum, you have to find Q first. Now we have our units, 26 units. So now we're going to look for the maximum profit. Maximum profit. Maximum profit. Maximum profit. Yes, I'll attend to your questions now. Maximum profit. We are going to say, remember, its P is equals to negative 2Q squared plus 104 Q minus 200. So now we are going to substitute. We are going to have negative 2 times 26 that we obtained from the first step. And then all squared, then plus 104 plus 104, sorry, 104Q. Our Q is 26 units. And then minus 200. What is the answer?
It's 1,152.
1,152.
Okay.
1,100.
Okay. This is minus 200. So maximum profit is going to be 1,152. So this means that when the firm produces and sells 26 units of products, they will make a profit of 1,152 rands. That's our maximum profit. Then if I was to draw a function here, the function will look something like this. Again, this is just an example. This is the maximum profit. So because my function, its P is equals to, by now you know that P must be here, then Q must be here. So this will be something like this. Our A is negative, so it's going to face something like this. Again, so yes, this is my maximum turning point. So this is 1152, yes. And then this is 26.
Can you please also make an example of the minimum turning point?
Minimum turning point.
Yes.
Okay. I don't have any because we want to make profit all the time. Let me see if I'll come across that.
In case
Yeah.
there's a loss.
Yeah, because everything that I have is negative. Okay, let me look for an example here.
Hi, ma'am. Even though we can
Yes.
do it later, it's fine.
On page
Yes.
page 43, number 2, I think we have a minimum example.
I think, ma'am.
We have a minimum.
Example on page 43, number 2.
43. Yeah, yes, I didn't take it. Yes, here's the example. What makes it a minimum? It's this. Remember, I said that the A, whatever is next to A squared is your Q squared, sorry. Whatever is next to Q squared is your A. So if you can see, this is a positive 5. That's why our graph is facing up. This is where you get the minimum. You will see here they're saying the minimum is found at the turning point. So the turning point is here. That's the minimum because of your function is a positive Q squared. It's not a negative. I hope it makes sense. I didn't take this example because I felt like I was going to repeat the same thing over and over again. So whoever's asking yes, you can ask. Yes.
I just wanted to also know, or when I'm calculating the minimum, I also have to find the Q first, like when I do the
It's here.
maximum.
Yes. If you can check, here it is. You find the Q. After you get the Q, then you just put it there to get your minimum. Yes, same
Okay,
steps.
okay. Thank you. Can continue. Thank you so much.
Okay, thank you. All right. And then we go to market equilibrium.
Question, ma'am. Question.
Is it still on the previous question? Yes.
Yes, please. It is.
Okay.
So my question is, considering how our quadratic profit quadratic equation is, so we have a -2 and -2 squared plus 104q minus 200. So would you advise to further break down the equation by dividing all values by -2, or must we leave it
No, you
like
can't.
this?
We leave it like this because remember, if you're going to divide by 2, you must also divide this by 2. So now you'd
On
be
the Y.
affecting the P. Yes, everything
yes,
must be
yes,
divided
yes,
by
yes.
2. Yes. So we
Okay.
Sorry,
can't.
Mr. Unless I'm lousy at arithmetic, I think that answer's wrong.
Okay. Which one?
1152.
1152. Are you sure?
Oh, ma'am, she just didn't finish
Oh, it's the
writing. It's
2.
200. It's not 2.
It's 200, not 2.
Oh, thank you. Okay, you're not lousy, eh? Thank you. You're not lousy.
Masra, can
Thank you.
I ask can we go back to B, the final
B?
answer? Yes.
Okay.
You wrote -2 q squared, yeah, just the last 104. I get it with minus 107 minus 3, it gives us 104. Then I want to
Positive,
understand the
yes.
plus, the sign changed to a positive. Why is that? I thought the signs only change if they go after.
No, it didn't change. If you take your calculator and say, what I did is I just minus these 2. If you take your calculator and say 107 minus 3, is your calculator going to say negative or positive?
Oh, it's a
Or
positive.
did you, yes, or did you want me to write it like this? Say 104q minus 2q squared minus 200 is the same thing.
Oh, okay, yeah, makes sense.
Yes,
Okay, thank you.
yes. I think I see what you're saying, but yeah, it's the same thing. I just decided to write it this way, but it's
It makes
these
sense,
two are
thank
the
you.
same. Yeah, even if you write it this way, you're still gonna get the same answer because you already know that this is A because it's next to q squared. Okay, all right. Now we're going to market equilibrium. So it says market equilibrium is the point in a market where the quantity demanded by consumers equals the quantity supplied by producers. I think we did this with supply and demand. And then they're saying at this point, actually we did it with linear function. Now we're also doing it with quadratic. So whatever we were doing with linear, now we're also doing with quadratic. So they're saying at this point, the market prices, so the market price becomes stable because there's no shortage or surplus. We did this with the linear. So now we're doing it with quadratic. So let's see how it goes. It says here that we have an example. The supply and demand functions for a particular market are given by equations. These two equations. Someone's hand was up. Was it based on this market equilibrium now? Someone's hand was up. Whose hand is up? Okay, and then mute your mic, please. If someone's mic is on, it's just disturbing. All right. Okay, so we have an example. It says the supply and demand functions for a particular market are given by the equation, sorry. We have this equation and that equation. So because we are under nonlinear functions, that's why we are seeing a Q squared. I repeat, the squares, they mean that these are our quadratic. And then there's going to be a curve. It's not a straight line. Okay, we're dealing with business here. Sometimes we have bad days and good days. So yeah, okay. So the first question says, find the equilibrium price and find the equilibrium price and quantity algebraically. Okay, yes. So meaning we have to solve, not with the graph. So I said to someone that every time they mention equilibrium, you equate. Every time they say equilibrium, it means we must equate the two functions. So we're going to equate. We know that equilibrium, it means that I must say P S is equals to supply is equals to demand. And then now we solve. This one we did it. So I'm just going to solve it. So we are going to have our supply is Q squared plus 6Q plus 9. Then it's equals to our demand is Q squared minus 10Q plus 25. And then now we do the apples and bananas. So I'm going to move the ones with the Q's to my left. So I'm going to have Q squared plus 6Q. And then I'm going to move this negative 10. When it jumps an equal sign, it becomes a plus 10Q. And then I'm also going to move, I must start with the Q first, sorry. Okay, I must start with the Q first. The Q, I'm going to move this Q is going to be Q squared. And then I move this 10 is going to be a plus 10. And then I'm going to move numbers on one side because I have to solve for something. So this is 25. Then I move the 9 to my right. It jumps an equal sign. It's going to be a negative 9. And then now we solve. Q squared minus Q squared. We do the apples and bananas. So these two are the same. It's 0. So these two, they're the same. And then these two are the same. This one and this one, they're the same. Okay, so this will give me 0. And then 6 plus 10. A sign before a number belongs to that number. So 6 plus 10, it's 16. So I'm going to have 16. Q, there's no need to write the 0. Then this is equals to 25 minus 9. What is 25 minus 9?
16.
16. Now 16. I need to solve. Yes, now I need to solve for Q. It means I must divide both sides by 16. So let me rewrite this again to avoid confusion. So I am going to divide by 16 both sides to remove the 16 because I want Q. And then my Q is going to be equals to 1 because 16 divided by 16 is 1. The whole point of dividing by 16, I wanted to cancel this side. That's why we divided by 16. And then now we have our Q. So we know it's tradition. Once you have your Q, you must also look for P. When you look for P, you use one of the functions. Whether you choose to use the P, it's up to you. If you want to use this PD or PS, doesn't really matter. We're going to get the same answer. So I'm just going to do it here because I don't have a space. Then I'm going to say, therefore, Since well, my P, I'm gonna use this P is equals to Q squared plus 6Q plus 9. So I'm going to replace my Q with 1. So this will be 1 squared. 1 squared. So this will be 1 squared. Then plus 6. Then I replace this Q again with 1. And then plus 9. What is the answer?
16.
16.
16. Is it six? Yes, 16. Yes. So this is where our market price becomes stable when Q is 1 and our price is 16. We did this with the linear function. So we are doing this with non-linear. We are doing the same thing. Nothing has changed. Now let's go to break-even point so that I can answer your question of
Sorry,
that
Masego.
formula. Yes.
Can I ask you a question on the last part? So it doesn't matter if you use the supply or the demand function in that regard, or am I not understanding you
Yes.
correctly?
Yes, it doesn't matter. We're gonna get the same answer.
But then why did you add the plus 9? Oh no, from the first step. Okay, I see. Thank
Yes,
you.
yes.
Thank you.
Okay. Roger. Okay, now let's go to break-even analysis. So the break-even point is the level of production or sales at which a business total revenue equals its total cost. At this point, the business makes neither profit nor loss. So we know that, so this means that break-even point is total revenue is equals to total costs. And then we also know the formula of total revenue, by the way, it's FC plus VC. Fixed cost plus the variable cost. Now let's look at the example so that I can answer most of the questions. Example says a company produces a product at fixed cost of 30 rand. So already you know that this is your FC. You must always do that for yourself. This is FC. And a variable cost of 2 rand per. So this is my VC. So it means my VC is equals to 2Q. VC is equals to 2Q. This one, this is my variable cost. And then it says that the demand function for the product is given as, this is my demand function, Q is equals to 65 minus 5P, where Q is the number of units produced and sold, P is the price per unit. So here, my dependent is Q. So this is in terms of P, not in terms of the price. It's in terms of the units quantity. Yes. So now the question here says, write the total revenue and total cost. So I must look for TR and TC. They're saying in terms of Q. So it means that before I solve for my total cost or total revenue, I must make sure that every time my Q is independent. When you say in terms of P, it means that your answer must be P is equals to. In terms of Q, it means it's P is equals to. But if we can check our demand function is Q is equals to. And for me to calculate the total cost, I need to have my, what is it? Okay, wait.
Variable cost.
Yes. Okay, so now let's start with the total revenue. Total revenue is equals to, and what is total revenue? PQ, ne? Yes. Our total revenue is equals to P times Q. But we don't have the Q, the P. We know that our formula must be in terms of Q for us to solve for the total revenue, just like we were doing before. So it means that we firstly need to solve for this one, for the demand function, and put it in terms of Q, not in terms of P. So I have Q. I need to change this formula. Q is equals to 65. Please mute your mic. Whose mic is on? Thank you. It's 65 minus 5P. So now I need to make sure that my P is on the left and this one goes that way. So I'm going to swap them first. That's what I'm going to do. When I take this to the other side, it changes the sign. It becomes a positive 5Q. And then when I take, because I'm only swapping them, when I take Q to the other side, it's going to be a negative. This Q is positive. It's going to be a negative. Why am I doing this? I want to have my function as P is equals to. So after this now, I have, now my function is 5P is equals to 65 minus Q. Now I'm going to remove the 5. I want it to be P is equals to, not Q is equals to. So I'm going to divide now. You can't just swap P and Q. We solve. So this will be divide by 5, divide by 5, divide this one by 5. Remember, there's a 1 here. So this is like 1 over 5. So this will be P, because these two are going to cancel. So this will cancel that. So it's going to be P is equals to, then 65 minus 5, 65 divided by 5. What is 65 divided by 5?
13.
13. Okay. This will be 13. And then minus 1 over 5. 1 divided by 5.
0.2.
0.2. Minus 0.2.
1 over 5
Thank
Q.
you.
Oh.
Q. All right. So this formula is in terms of Q. This is what we mean when we say in terms of Q. This is in terms of Q. So it means Q is independent. When they say in terms of Q, this is what they meant. This is in terms of Q. Now we have our demand function in terms of Q. Please mute your mic. And then now we are going to solve for the total revenue. We have our P, so total revenue is going to be equals to our P bracket 13 minus 0.2 Q and then times Q. Yes, quick one. Yes.
Do you
I don't
always have to
understand
decimate it?
when they say in terms of Q. Can you explain that again? When they say in terms of Q, because I thought our demand function is already in terms of Q.
No, it's not in terms of Q. So when we say in terms of Q, we mean that Q must be independent. It means in terms of Q, it means that my answer must have Q. So this is P is equals to my answer has Q. But then here it's Q is equals to my answer has P. When I say in terms of P, in terms of Q, I mean that it must be something is equals to Q. There must be Q on my right-hand side. That's what we mean when we say in terms of Q.
Okay.
Yes.
Okay, thank you.
Then, okay, someone else was asking a question?
Hello, ma'am.
Or
I was
did
just
I
wondering
answer?
whether it should always be decimated. I worked through the example, but I didn't decimate in the end.
It's still fine. Remember, it depends on your, remember if you were answering your assessment, you'll see with your multiple choice. If your answer is not given in decimals, then it's a fraction. If it's not fraction, it's decimals. So if you have 1 over 5, and then your multiple choice doesn't have 1 over 5, it means that you must make it a decimal number. That will depend on the multiple choice. Yes, the answers that you have as options. It will depend on that. So always check if it's in fraction or decimal. Okay. All right. So now my total revenue is equals to, then we distribute like we did before, 13 times Q, it's 13Q. And then negative this times Q is negative 0.2 Q squared. That's my total revenue function.
Yeah, 13.
Oh, why am I missing the Q? Thank you. And it's not the first time I missed the Q, sorry. Thank you. Okay, let me write again. TR is equals to 13Q. Thank you. 13Q then minus 0.2 0.2 Q squared. Yes, that's our total revenue. Now we have to look for the total cost. Total cost. So our total cost, the formula is total cost is equals to a fixed cost and then plus variable cost. So these ones, we get them from the formula, from the statement, sorry. The statement is TC is equals to our FC is 30. And then our variable cost is plus 2Q, sorry, not 3, 2Q. So that's our total cost and total revenue. Now we're going to,
Hello,
we are
ma'am.
going to, yes, are you asking based on A?
Yes, yes.
Okay, yes.
Thereby total revenue when it's 5P equals to 65 minus Q. Can't you do it as a fraction maybe?
Yeah, he asked the same thing. I said that it will depend on your options that you're given from your options when you're writing your assessment. If you are
Okay.
given this in fraction, then you will know that it's a fraction. But if all your options is decimal, there's no 1/5, it means you must change that 1/5 into 0.2.
Okay.
Yes, both of them are correct. They're not wrong. They're both correct, but it depends on the options. Are you going to be able to know that 1/5 is 0.2 or 0.2 is 1/5? So if you're given decimals, you can just make it a decimal. And from the previous, yes, from the linear functions, I noticed that we always made it a decimal. So yeah, it will depend on your options.
Okay.
Okay.
Sorry, Masihok, I just want to ask a question. It's not the question per se. I just want you to go up a little bit. I just want to take down that final answer because I was asking a question at the time you were still there, so I didn't write
Which
it
one? This
down.
one?
Yes. Yes, just there. Thank you.
Okay.
No, it's fine. You can proceed. I just screenshotted it, so it's fine. Thank you.
Oh, okay. All right.
Thank you.
And then let's go to B. B says find the break-even point algebraical, so meaning we're solving. This is what I was talking about. So let's see, when do we use that formula? Let's see what's going to make you use that formula. Now, break-even point, we said that total revenue is equals to total cost. That's the break-even point. Break-even point, it means that TR is equals to TC. So let's see. I just want to answer that question. TR is equals to TC. And then our TR, we have it from the previous question. Our TR is
13Q.
Okay. Thank you. 13Q
minus 0.2 Q squared.
minus 0.2 Q squared then equals to 30 plus 2Q. Yes. Yes. So now we are going to solve. So on this one, if you can see we only have 1, 2 like terms, the rest are not like terms. So what I'm going to do is I'm going to bring everything to my left-hand side because I need to solve for Q. So this is going to be 13 Q minus 0.2 Q squared. When you move everything to the left-hand side, it means you'll be left with 0. So this will be minus 30 because it was a positive, and then also minus 2Q. When you move everything one side, the other side must be equals to 0 because you have an equal sign there. The equal sign must stay. So it's a function. Now we add the like terms. These two are the same. They both have Q. So I'm going to have negative 0.2 Q squared. And then, I'm sorry. Yeah. And then 13 minus 2. What is 13 minus 2?
11.
11. So the 11 is positive 11. Again, it doesn't really matter. You can say 11 minus 0.2 Q. It doesn't matter. And then 30 doesn't have a friend. So if you can look at this is a quadratic function. Why am I saying it's a quadratic function? It has a square. Yes. So if I was to ask you to solve for Q, what would you do? That's my question. The person who was asking me, when do we use that quadratic formula? This is where we use the... Thank you.
Yes, yes.
This is where you use the
Yes.
quadratic formula. Those who are doing maths, they factorize, but with us in economics, we are going to use quadratic. We don't want stress. So we're going to use quadratic formula. This is where we use it because we have a Q. We have to solve for Q. And we can't solve for Q. It's a Q squared. There's nothing you can do but to use the quadratic formula. This is where we use it. When you have a Q squared after you solve. Q squared. Please mute your mic. Please mute your mic. Thank you. Thank you. All right. Now we're going to do what we're doing. I said that we use the quadratic formula. The quadratic formula is Q is equals to negative B plus or minus, then the square root, then it's B squared minus 4AC, then everything over 2A. Then now we have to look for ABC. So my A is negative 0.2. My B is 11. And then my C is negative 30. Now we can use the formula. Okay. Now we can use the formula. Insert the blank page. Yeah. Okay. Yeah, just want the space. And now we can use the formula. Okay, yeah. So we're going to use the formula. So this will be Q is equals to. So remember the formula is Q. I'm going to write it again. Q is equals to negative B plus or minus the square root of B squared minus 4AC and then over 2A. And then now we replace. Our B is 11. So this is negative. Then in brackets, you put 11. 11. And then this is plus or minus the square root. And then our B, again, it's 11. 11 squared. And then minus 4. Then our A is negative 0.2. Negative 0.2. And then a bracket again. Our C is negative 30. And then, yeah, everything is under the square root. And then over, then 2. Then our A is negative 0.2. And then now we are going to use our calculator. Not everything though, but you can, if you want, you can use everything. So when we use our calculator, we'll have negative 11, plus or minus the square root of, you solve everything under the square root with a calculator, you're going to get 97. And then everything over, what is it? Is it negative? Negative 0.4. So we are going to have two answers when we solve because of the plus or a minus. So you're going to have two answers. The first answer, you're going to use a plus. You're going to say negative. Let me just do it here. Sorry. Can I do it here? I don't want a lot of steps. So I'm going to do it here. I'm going to say this one, I'm going to do it with a plus. And then the second answer, this is Q is equals to. The second answer, I'm going to say negative 11, then a minus. Plus or minus means that you're going to have two answers. This is the square root of 97, if I'm not mistaken, then over negative 0.4. So my two answers, the Q is going to be equals to, for this one, it's 2.9. if I'm not mistaken.
Yes.
Or this one, the answer is going to be
52.1.
52.1. So these are the two quantities, two Qs. So we have two answers here. These are what we call the roots. Yes, Shane.
Ma'am, I just wanted to ask, do we always have to round it off to 1 decimal? Or can we do 3 decimals?
You can do 3 decimals. And again, I'm going to repeat, when you're writing your assessment, you must always check your options. If your options are 1 decimal, then you will round off your answer to 1 decimal. Your options will give you an idea, but if it was not a multiple choice, it would be 2 decimals. Normally, the standard is 2 decimals. Some, they make it 1, but it depends on your options in the assessment or the exam.
Okay, thank you, ma'am.
Okay. All right. Then we know that it's tradition. Once I find Q, I must find P. It will never change. It will always be the same. And please, for this one, you must note when you are looking for the other ones, please, to revenue or please, you must note you're going to use one of these two. Either you're going to use this one. I don't know if it's going to give us the same answer. Okay, I didn't check. Let me check first. 13 times 0.2,9. I didn't check because I don't think your study guide looks for this answer. And then 0.2 times 2,9 squared. Okay, I get 36. Okay. Hi, I hope it's the same. Okay, here I looked for Q only. I think your study guide looks for Q only, but yeah, you can also look for P or TR. Ne? So the TR/T, so you're gonna use one of these two. We should get the same answer. 13Q minus 0.2Q squared, or this one, or TC. Just that in your study guide, they don't calculate it further, but yeah. Total revenue or total cost. So we have two graphs. So our graphs are going to be two of them. So if you are going to look for, yes, you must look for 2,9 with this one, 2,9 with this one, 52,1 with this one, 50. So it means that for total revenue, you're going to have two answers. And then for total cost, you're going to have two answers. So it means that here, total revenue, I'm going to substitute my 2,9. So this is 13 times 2,9 minus 0.2 Qs, not Q, times 2,9 all squared. You get the answer. Okay, you're going to get the answer. Sorry. I'm going to show you the function now. Can you please, please assist with the, okay, please assist with, sorry. Sorry, guys, okay. Yeah, please assist with the calculator there. Okay. Okay, now it's doesn't want to. Okay, let me just continue. Okay. Okay, what did you get?
36,01.
36,01. Okay, doesn't want to.
Maybe it's
work.
86,02.
0.02. Yeah, obvious.
Okay. Starting again. What's the date today? Sorry about that. Okay. Yeah, as I was saying, we're going to have two answers for each. So we're going to have so it's going to be TR is equals to 13. Then we substitute the 2,9 first. 2,9, 2,9. So this will be minus 0,2, then 2,9 squared. And what is the answer that you got?
36,02.
36,02. Okay. And then we're going to substitute another one, TR with the 52. So it's going to be 13 times 52,1. And then also 52,1. So we're going to substitute for this one and minus 0,2 all squared. What is the answer for this one?
134,42.
134,42. Okay. And then you also do it for the total cost. Total cost is 30 plus 2Q. So total cost for 2,9. So this will be 30 plus 2. But remember, you're not going to draw the graphs. So I'm just doing this to show you how the graphs are going to look like. And then what is the answer?
35,8.
35,8. And then this one is 30 plus, then we do the 52. I just want to show you how the graph will look like. So this is 52,1. It's 2 times 52,1. What is the answer?
134,2.
134,2. Okay. So when you draw these graphs, remember the one with the square, it means it's a quadratic, it's a parabola, it has a curve. So when you draw your graph, so this side will be represented by total revenue and total cost. So this is TR or TC, and then this one will be Q. Samkelo, your hand is up. You won't be required to draw the graph. I said it before. I'm going to say it again. Yes, Samkelo?
Yes, ma'am. On that 35,8, are we not supposed to convert it to 36? Because
Yeah,
that
it's
is
still okay.
above 5. I mean, it's above 5.
Oh, yes.
Yeah.
Yes, we can convert it. Yes, we can convert it. We can make it 36. Yes, can be 36. And then this other one's 34. Yeah, can be. It's fine. All right. So when you
All
draw
right.
the graph, because of this is negative. This is negative. Because this is negative, it means that it's going to be facing down. So it's going to look something like this. It's just a rough sketch. So the maximum and the whatnot, we know how we get that. Okay, fine. But these two points are where your graphs are going to touch each other. So this graph will look like this. This one is a positive gradient. This one, it's positive, so it's going to go up. So you'll have another graph going the other direction. So starting maybe from 0 going there. Or maybe not 0, starting from 30 going there. So these 2 points that we found, it's this point and this point. That's where our graph. So if you can check these ones, they gave you 36, even these ones that are too close to each other. So those are your 2 points. These are what you call the point of intersection. So if you can remember, we also had the break-even point when we did demand and supply, if I'm not mistaken, or was it, yeah. Where the two graphs were touching each other, that's where they were equal. So we only use this formula if we have to solve for Q and we have the square. That's where we use this. So I think it's on break. Actually, I don't think break-even point. That's where we use the quadratic formula. If you can factorize, you can try. But we use quadratic. The answers are decimal numbers, so we always use quadratic.
I did actually factorize.
Okay. Did you get the same answers?
The answers are more or less the same. They're not precisely the same. It's 50 and 3.
Oh, okay. Yeah, it's actually the same because if we round it off,
50.
Yes.
So it's never really the same, but it's more or less the same.
It's close. Yes. Yes. Perfect. Perfect. Can I stop the recording you if we went over? Is there any question? Because I think we did talk about the minimum. Yes, Oka. Yes, Oka, you can ask a question. I'm going to
So,
stop the recording. Yes, you can
okay.
ask.
Hi,
Yes, you can
ma'am.
ask.
I just wanted to ask, is the